Hi folks, welcome back to 6.1 area between curves. We're going to take a look at one last practice problem here. So this practice problem is very similar to what we just learned in example 7, which is that sometimes if we shift our perspective and we kind of look sideways at things, it makes our life easier, okay? So let me write down the formula that we wrote last time just to remind us that area could be the integral from a to b of the top curve minus the bottom curve dx. Or, if it suits us better, we can say area equals the integral from c to d of the right curve minus the left curve. And what's important to recognize is that at the end of this, you should have a dy, not a dx. All right, so let's shade the region that we're interested in finding the area of, which is going to be this part here. Ooh, gets a little skinny. Right there. And we're trying to find that green area. Now, I'm going to try the horizontal line first. But I realized immediately with that first one that the top curve is green and so is the bottom, so it'd be really hard for me to subtract those. So I'm going to undo that, and I'm going to try a horizontal line. Okay, right curve is green, left curve is purple. All right, let me try one more line just to make sure. Left curve is purple, right curve is green. Okay. So I'm going to use this dy for this example. Now let's go back and figure out which equations are which. So we have a purple equation, and that is the cubic one, so kind of looks like this, all right? And then the green one, the one that looks like a parabola, is this one that's like a sideways parabola, all right? All right, let's plug things into our equation. So the area equals the integral from, I'm not sure what my bounds are. We'll have to come back and figure those out. So my right curve is the green one, so negative 3y squared plus 4, minus the left curve, which is the purple one, y cubed dy. All right, let's go find our bounds. Now we can find our bounds the same way we did before, which is we're going to set our f of y and our g of y equal to each other. So I'm going to set negative 3y squared plus 4 equals y cubed. All right, let's see. 4 equals y cubed plus 3y squared. And this is going to give me y cubed plus 3y squared minus 4 equals 0. Okay. So in this case, all right, now this is an example of one I would not expect you to be able to factor by hand, okay? You certainly could if you went back to your pre-calc and did your rational root theorem and then did all of that work, but I think it's not really helpful in us achieving an answer for this particular question. So what I'm going to suggest is that we use our picture to kind of help us guess some numbers that might work. So for example, I noticed that here's one intersection and that looks to be about 1. So I'm going to check that by plugging 1 into this equation. 1 cubed plus 3 times 1 squared minus 4, does that equal 0? So 1 plus 3 is 4, 4 minus 4 equals 0, so yes, my top bound is going to be 1. Now, I'm not really sure about this bottom bound, but maybe a good one to try would be like negative 2. Okay, and again, keep in mind I'm keeping y values here, not x values. So let me try plugging in negative 2 and see if I can make this equation true. So negative 2 cubed plus 3 times negative 2 squared minus 4, we hope is equal to 0. Negative 8 plus 12 minus 4 equals 0. Yes, it does, so that is my bottom bound, negative 2. All right, now let's go back to our equation, and we can say that the bottom bound is negative 2 and the top bound is 1. All right, let's simplify this before we do any integration. So negative 3y squared plus 4 minus y cubed dy. All right, let's integrate. Negative y cubed plus 4y minus 1/4 y to the 4th. Draw the line, 1, negative 2. I'm going to plug in the 1 first. So negative 1 cubed plus 4 times 1 minus 1/4 times 1 to the 4th minus, let's plug in negative 2. Negative 2 cubed plus 4 times negative 2 minus 1/4 times negative 2 to the 4th. All right. Let's be really careful with our signs here because I see a lot of minuses, so I want to make sure I do this correctly. Negative 1 plus 4 minus 1/4. That's what I get for the first few terms. Minus, let's simplify inside our brackets first. Negative 8 minus negative 8 will be 8. Minus 8 minus 16 over 4. All right, negative 1 plus 4 minus 1/4 minus 8 plus 8 plus 16 over 4. This negative 8 and that 8 go to 0. These two become 3 minus 1/4 plus 16/4 gives me 3 plus 15/4, which gives me 12 over 4 plus 15 over 4, which gives me 27 over 4. And that is the area that is represented by that light green region, and we have found that by shifting our perspective and using dy instead of dx. All right, folks, so that's it for the 6.1 practice. I hope you find these videos useful. Let me know if you have any questions, and I'll talk to you soon. Bye.